Good morning everyone. My name is Khalid Hassan Munshi and my ID is 241-15730. Today we will be talking about adder circuit, one of the most essential component in digital electronics. Adders are used to perform addition, in some cases subtraction. They used in many systems like arithmetic logic unit, digital processor, microcontroller, microprocessor, DSP system, real-time computing, and some cases counter and timers. Next slide please. Types of adders. There are mainly several types of adders, but in basic cases, the basic adder, parallel adders, binary subtractor, adder subtractor. Now comes in basic adder. There are two types of basic adder, half adder and full adder. Now my teammate Nusrat will talk about basic adder.
Assalamualaikum everyone. My name is Nusrat Jahan, ID 241-15324. My topic's name is adder. Adder two parts, half adder and full adder. Half adder. Half adder means add two single binary bits number. Add two input and two output. Here is the block diagram. A and B is the half adder input and sum and carry is the half adder output. A sum means A XOR B and carry means A dot B. Here is the circuit diagram. A and B XOR sum and A and B and word C. Limitation cannot add previous carry. Half adder total. Here A and B and also sum and carry. 0, 0, sum 0 and carry 0. 0, 1 means sum on and carry 0. 1, 0, sum on, carry 0 and 1, 1, sum 0 and also carry 1. Next slide. Full adder. Full adder is the implementation of half adder. Here is the purpose at 3 bits A, B and also carry. Output sum A XOR B XOR C and carry out A, B plus carrying A XOR B. Here is the full adder total. 0, 0 also 0, 0, 0 also sum 0 and C in 0. 0, 0, 1 sum on and also 0. 0, 0, 0, 1, 0 sum on carrying 0. It's continuous. Here is the truth diagram. Diagram half adder, two half adder and also OR gate. It's the full adder diagram. And advantage suitable for multi-bit addition. Thank you.
Assalamualaikum sir, I am Sabri Islam Copy. My ID is 241-15849. Today our presentation topic is adder circuit and my part is parallel adder. This is an important part of digital circuit which is used to add multi-bit binary numbers. And what is parallel adder? A parallel adder is a multi-bit adder that is created by connecting several full adders in series. And it is also allows the circuit to add in all inputs in parallel. Here we have an example of 4-bit parallel adder, which is each stage has two inputs. First bit from the first number and second bit from the second input into the second number in the circuit. And it is also handles the carry bit, which is in from the next stage to the output of the each stage. And now I will explain the advantage of parallel adder. It has first multi-bit addition, which makes the addition more faster, and secondly, it is very simple structure, which is easiest to implement the digital circuit. And the next part. Now I will explain the working part of parallel adder by giving an example. Here is the parallel adder diagram circuit, and as we can see that the first part is first full adder and it is called MSB part, and the last part is MSB part. And first full adder adds the first lowest input A naught and B naught, and also initial parts carry C in, which is processed and make the output S naught and carry C1 from the other full adder. And the second full adder also adds the next bit A1 and B1 and process it, and finally we get the output S1 and carry C2 from the next full adder. So this process keeps going until we reach the most significant bit, and finally we get the final output like S0, S1, S2, and final carry C out. Thank you, sir, for sharing me this.
Assalamualaikum everyone, my name is Akib Hassan Rafi, my ID is 241151144. Today our presentation topic is adder circuit and my part is subtractor. What is subtractor? Subtractor mainly subtract two input. So in binary subtractor, for the 0 0 the output is 0 and the 1 0 is 1 and 1 1 is 0, 0 1 is borrow with 1. Moving to the next slide. So subtractor is mainly two parts, half subtractor and full subtractor. In half subtractor, and what is the difference between half subtractor and full subtractor? The major difference is in half subtractor we can work with two inputs, and full subtractor we can borrow one, or otherwise we can say it we can work with three inputs. So in half subtractor the inputs is AB and the output difference between A XOR B, and we can borrow B A bar. In full subtractor the inputs is A and B and the borrow in, and the output difference is A XOR B, B XOR B in, and borrow out is A bar B plus A XOR B. B input, and here is the truth table for this full subtractor and half subtractor. Thank you everyone. This is my.
Assalamualaikum everyone. My name is MD Waliullah, student ID 2411569. So my topic for this presentation is adder subtractor circuit. Well, what does adder subtractor circuit means? It simply means we can add and we can also subtract. Well, let me see the diagram, and the basic element is when the it happens the addition when the mode is 0 and the subtraction when the mode is 1. Well, what does that mean? Well, here is the input point of the Cin. If we input 0 in this circuit, then it will does the job of addition. Why? Well, in the binary, when we try to subtract a number from another number, we need to use the 2's complement. While we need to toggle and then we need to add 1. These are the 2's complement. So we cannot do that complex thing in a circuit. It's simply when we add a 1 in here, it simply does the job. Well, how? When I input 1, it goes here, and we know when anything with XOR gate we input 0, it becomes the same, it remains the same. But if we input 1, then the output comes in the reverse version or the opposite version, or in binary we call that bar. So this is the basic element or working principle of this circuit. So when we add 1, it goes here and it does the job of 2's complement. So this is the basic elements or basic functionalities of adder subtractor circuit. Here some detailed explanation. We use XOR gates before B input. When mode 1, B becomes B bar, 2's complement subtraction. Carry in of LSB is set to 1 during the subtraction. These are all theoretical languages. I have taught this language in my works. Next slide, please. So you can see the complex version or the industrial circuit version of this adder subtractor method. Well, here are the mathematical forms of when for addition when n equal to 0, B XOR 0 it comes out B, C remains 0, so it becomes A plus B. But when in case of subtraction A minus B, we add 1, B XOR 1, it comes out as B bar or the opposite of B, and C is 1. Then here you can see A plus B bar plus 1 equal to A minus B. This is how we does the job of adding or subtracting in this circuit in the method of binary. Now I am in the concluding part. Well, I am just discussing about whatever my friends just talked about. Well, we have talked about basic adders, half adder, full adder. Adders allow multi-bit addition, and subtraction perform binary subtraction with borrow. We talked about that. Adder subtractor combines both operations efficiency, essential for CPU and digital system design. Well, it's we are the students of computer science and engineering, and computer works in binaries, zeros and ones, and whatever we do the add methods or we subtract anything, It simply goes in the CPU. We know 0 means off and 1 means on. So this is the this adder subtractor and the other necessary things are basic elements or basic operations for computer CPU and any kind of CPU. So that is all from us. We apologize for the mistakes we have made. I appreciate your patience. Thank you.